Today we're going to be learning about transformations of parent functions. Our objective is that we'll be able to transform parent graphs given an equation. So there's three values that we're going to see in our equations today: A, H, and K. A stretches or shrinks the graph. This is called a dilation. It can also flip the graph over the x-axis. H moves the graph left or right, and K will move the graph up or down. So our first example, y equals 2 x minus 3 quantity cubed plus 1. Because of the cubed up here, we know this is a cubic function. Just like A is at the beginning of the alphabet, our A value will be at the beginning of our equation. So our A value is 2. H is inside with x. Remember, it's always the opposite of what it looks like, so it'll be 3. And K is whatever's on the end. It stays the same. So our K value is 1. We're going to start at the coordinate HK. So we're going to start at 3, 1. Then we're going to use Desmos to get the rest of our graph. If you're trying to graph without a calculator, see the link in the description below. So over to Desmos, y equals 2 times x minus 3 cubed plus 1. So as you can see, that middle point where it curves is at 3, 1. Yeah, there it goes. 3, 1. That's not a nice exact point. Let's see what we can see. It looks like it crosses at 2, negative 1. Also looks like 4, 3. So that kind of helps me sketch out my curve. So the fact that there's a 2 stretched it. Our H value of 3 moved it right. And our K value of 1 moved it up from the original parent graph. Our domain, since we have an arrow on the left and an arrow on the right, it's negative infinity to infinity. Our range, because we have an arrow pointing down and an arrow pointing up, is negative infinity to infinity. And then our end behavior, as x goes to positive infinity, that's our right arrow, which is pointing up. So f of x is going to positive infinity. As x goes to negative infinity, and it is still negative infinity, even though we don't see this cross over into the negatives for the x values here. It does eventually, it's just at a very low y value. So it's still as x goes towards negative infinity. F of x is going towards negative infinity because it's pointing down. Alright, so this time we see the two straight lines, which means this is our absolute value function. Our A value is still in front. So it's 3. Our H value is the opposite of what's inside. So it will be -1 this time. K is the number on the end. Since we don't see anything, it's like there's a +0 there, so K is 0. Basically, if you don't see H or K, it's 0. If you don't see A, it's 1. So my starting point will be the point -1, 0. So I'm starting here. I'm going to put this into Desmos. So my bottom point, my starting point, was where we thought it would be at -1, 0. I can see here that there's a point at 0, 3. And if you look carefully up here, it hits 1, 6. -3, 6. -2, 3. And it helps to know that this, since it's a V shape, it's symmetrical, so whatever it does on the left, it also does it on the right, vice versa. So my domain, I've got an arrow on the left and an arrow on the right, so it's -infinity to infinity. The range, the bottom Y value is 0, and it goes up forever to +infinity. For my end behavior, because both arrows are going the same direction, it makes things a little bit easier, because if they're both pointing up, then both ends are going towards +infinity. Alright, so my A value's still out in front. Is a -1/2. Because of this squared up here, I know this is a quadratic function, so it's going to make a U shape. Since there's no parentheses, I know that there's no H value, so it's 0. And then K is the 5 on the end. So I'm going to start at 0, 5. I'm going to put this into Desmos. Alright, So there's my 0, 5 point. Now it's kind of hard to tell where points land, especially like if you see here they're decimals. So something that's helpful is we can take this gear and click the table button, and it'll convert it to a table, and we can try and find some other points that are helpful, like -2, 3, and 2, 3. Let's see. We can get a couple more. There we go, 4, -3. And just like the absolute value function, we know this will be symmetrical. So if there is a point at 4, -3, we also know the other side. There's also one at -4, -3. So there's our parabola. So for our domain, we still have an arrow on each side, so it's still -infinity to infinity. Our range is going to change a little bit because this time the arrows are pointing down, so it's going from -infinity, and then it's going to stop at our top y value, which is 5. But for our end behavior, since the ends are pointing the same direction again, since the ends are both pointing down, it's pointing to -infinity. So it's a little hard to tell on just this small graph patch. Actually, let me show you. Let's go back to Desmos. I'm going to put in just y equals, I'm going to do it as negative to make it a little bit easier to see. Okay, so I got rid of the 1/2 so that you could see kind of what the 1/2 did to the graph. So the red parabola is the same size as our parent graph. It's just moved and flipped over. What the 1/2 did was it made it wider. It, some would say shrank it. It's kind of like it smushed it. It's kind of like someone like stepped on our graph and smushed it down. So because it's 1/2, because it's smaller than 1, it shrank the picture. And then because of the negative, that's what made it flip over the x-axis. It didn't move it all horizontally, so it didn't move left or right, and then the 5 moved it up. So let's look at a picture and describe what happened. So y equals the absolute value of x is one of our parent functions. This we know is an absolute value graph because it makes the V shape. And our starting point that's usually on 0, 0 is now down here. So if it's usually here, we know that the graph moved left. It also was moved down. Because it goes over 1 box and then up 2, we know it was stretched by 2. And the stretched by how much is not important, but the fact that it was stretched. And then it flipped over. So that's the sort of thing we'd be looking for if it says describe the transformation. Here, where it's saying determine the transformation, that's more of write the equation. And I know that's tricky because describe and determine are very similar words. So let's look at the graph. The point in the middle of our absolute value, our vertex, is still our HK point. So that's the point -3, -1. Because the graph flipped over, we know our A value is negative. And then because when we go over one box, we have to go 2 boxes to get to the next point, we know A was -2. So, our equation, remember, A comes at the beginning just like it does in the alphabet, so y equals -2. Then we're going to have our symbols for the parent function, so that's our absolute value. Then x. H is the opposite of what it looks like in the equation, so if h is -3, then we write +3 in the equation, close the absolute value, and then -1 for our k value on the end. If you're ever unsure of this equation, put it in Desmos and see if the Desmos picture and the points matches up with the picture and the points that you're given in the graph. That's all for today. See you in class.